Hey guys, welcome. This is the intro to Scala Meta live coding talk. A word of warning, if you guys were in Chicago, this talk unfortunately will be very similar because we're going to be live coding an annotation macro. I was hoping in the Europe in Copenhagen, I was going to do the live coding of def macros, but Eugene told me 2 days ago that it actually got into Scala Meta finally, so I didn't want to change my topic the day before the code on the flight. So speaking of which, Eugene might want to give some updates on Scala Meta. So.
Thanks, guys. Can you hear me? Hello. All right, cool. Thank you very much. I'm here, just as Pathikrit said, to make an announcement about our recent advances with Scala Meta. So the thing is that while I was flying here to Copenhagen from San Francisco, I actually implemented def macros based on Scala Meta. So for those who track our progress, you probably know that a year ago already in Scala Days New York and Berlin, we had macro annotations working. Actually in IntelliJ, Scala C, and Dotty, all of them. But def macros, they were kind of an elusive target because of reasons. Actually, it was quite hard architecturally. And so finally, we've found the right design, thanks to collaboration with the PFL, in particular with the Finn, one of the Martin's PhD students. And so I'm really happy to announce that we have something working. So just a super quick update. Yesterday, I submitted a pull request, and I would just like to show you one of the tests, which showcases an implicit macro that creates JSON serialization logic based on the Scala Meta semantic API. We've actually created a new organization called, well, not an organization, but a project called Scala Macros, which will be tracking our progress with the new macro system. So as one of the issues here says, so I don't know, is it legible? Can you read this?
Yeah.
So it says that it's been a very nice trip, well, 6 years of research, lots of awesome stuff, but really with Dotty just around the corner, we need to settle down ASAP and just stabilize what we have. So our goal now would be to ship something working, and towards that end, other issues in the issue tracker, they say that we need a migration path from Scala Reflect. We need a migration path from, the current implementation of annotation macros. And the final project is something that the guys at the PFL have been working with. So we just combine the results of this research, and we ship something stable that will work for Scala versions like 2.11, 2.12, the upcoming 2.13, and for Dotty. So that's the plan. We know what to do, and we just go for it. So I really appreciate the chance that Pathikrit gave to me that, well, I can announce this and, well, hopefully instill confidence in the direction of the project. So now to promised code. So here's the pull request that has, well, of the new macro API and also an implementation for Scala 2.11. So it features the promised design, the breakthrough that I mentioned before, and onto the example of the materializer. For those of you who've written macros, this shouldn't be a surprise, but I'll just go a little bit on the details. So here we have the first import, scala.macros._. Then next to it, we have Scala language experimental macros. So this is still an experimental feature, but once we're stable, we're just going to drop that because, well, there's not going to be an experimental feature anymore. You'll be able to rely on it in the future. And so we start with a simple type class that does serialization of something to string. That something is going to be JSON. And, well, we define a couple helper instances like this. So for an int, for a string, super straightforward. And now the interesting part is an implicit macro, which we call a materializer. In the new macro system, we define macros within line, the new keyword introduced by Dotty and also supported by our compiler plugin. And then at the right-hand side, we say meta, which designates code that runs at compile time. And so the key difference between what I'm showing and what Pathikrit will be outlining later in the macro annotation live coding session is that in def macros we actually have semantic API, which means that we can do things like this. We can take, for instance, all the vals that were declared in the type that we passed, that is all the vals of a case class, and then filter them using some logic. And then we not only access the names of the fields, that can be done just with QuasiCores and syntactic API, but we also have the access to the type of the field. Well, basically, that's some functionality that we've gotten pretty accustomed to in Scala Reflect macros. But the problem with Scala Reflect was that it relies on compiler internals. As a result, it's not portable to Dotty, for instance. But this thing that's shown here in the pull request, it defines a platform-independent API, which can be implemented. I'm confident about that for Dotty, and for Scala C and for IntelliJ. So we hope that these red squiggles that you sometimes get when you use shapeless or some advanced macros, they will be gone thanks to this project. All right, so this is it. I'm actually giving the stage back to Pathikrit. It's his talk anyway. Thanks a lot for letting me speak here. I think the future of macros is actually bright. So we finally know the solution, how to deliver them. And we just need to capitalize on the years of research. So please stay tuned for future updates and take a look at the API that we already have in stock. Thanks a lot.
All right. So just to clarify, set the expectation for the talk. The talk is not about Scala Meta internals. There are people at this conference like Eugene who knows way more about that than me. It's not about Scala Macros per se. It's how to use Scala Meta macros in real life, specifically annotation macros. And hopefully this would let you guys to go experiment with this on your own and start using it, writing, using macros in your real-world, real-life projects. So one of the questions that hopefully everyone here is convinced that macros are not only nice, but sometimes necessary. But here's an example, like if you want to write a debug macro, like something like this, you just don't want to print the values like 23 hello, and it's like the function application. You also want like x, like the variable name x equal to 23 and y equal to hello, and the function application f, that's the name of the function being invoked when you want to debug. This is like a nice thing. And you may also want to do some other stuff like print out the line number wherever in the file you're printing this debug was called and what's the name of the file, hello world.scala. There's absolutely no way with doing this without macros. That's just one motivating example that says, that hopefully proves that macros are required and just not nice things. So at a high level, macros are just, when we say macros, we want to conceptualize it in one sentence. It basically takes abstract syntax trees, which are programs, and spits out new abstract syntax trees, new programs. In Scala, the macro system is not like a C++ macro system where you just replace and move on. It's a very hygienic macro system, as in you have access to the abstract syntax tree in a very nice algebraic data type, and you can do things with it. Here is the incantation needed to define an annotation macro. So if you're defining any normal annotation, you have to extend the static annotation class. So that's not new to Scala Meta, or Scala Macros. So as Eugene mentioned, there's this new keyword inline, and this is you implement the apply function. You take in the definition here. So the definition here, it says any return any is actually an abstract syntax tree, return an abstract syntax tree, and that's just how it works. And you have a meta block right there. And you can use your annotation just like this, like my annotation on a case class. So macros are everywhere. Almost every well-known library out there has a macro in there in some shape and form, so you use it a lot. So it's some more motivation that these are really useful things, and you should know about them as Scala programmers. So a lot of people shy away from macros, and there's a good historical reason for that. So before QuasiCores were introduced, this is how you would write using the Reflect API in Scala 2.10. And that left-hand side, this whole thing is basically the representation of a list with 1, 2, and 3 in it. And you can see how ugly it is. It has an expression, and inside that an apply, and because this is actually list.apply, and you're passing in literal constant 1, literal constant 2, literal constant 3. Yeah, then you have an identity, which is the list class, so on and so forth. This gave macros a very bad reputation for a long time, because this was just really hard to use, and you have to be someone in the EPFL Scala team to actually understand all this, because this is very closely tied to the way the compiler is written. We, as everyday programmers, we want to be abstracted away, like one level up from the compiler. And then QuasiCores are introduced. I think that they were just a genius idea. And so you have this string interpolator queue. You probably know you can write string interpolators. And you could, with this interpolator, you could create new nodes in the abstract syntax tree, or pattern match, or unapply. So for example, you can do something like q args body, and this is the function definition, and you would get the abstract syntax tree for the arguments and the abstract syntax tree for the body right here. So this is using the Scala's left-hand LHS apply syntax. You could also do pattern matching. So you can say if you have a tree, which is an abstract syntax tree, do something like q, is this an identity function? So here I'm checking if the function I got, is it an identity function or not? If not, they have this little nice thing called abort, and you can abort the compilation with a message. I gave a talk on using QuasiCores. So if you're not super familiar with QuasiCores, you can go back to Scala by the Bay 2015, where I did live coding with QuasiCores. So for this purpose of the talk, you don't really need to know QuasiCores, but this is a useful background to have. So these are the 3 resources I found very helpful while doing this live coding. So let's see. Yeah. So I opened them beforehand because I didn't know if the internet was going to be available. So this is the Scala Meta tutorial, and they have some really useful examples here. So this is the first link. And this is a good cheat sheet to have. This says, given the expression on the left, what QuasiCode to use. This is pretty important to have, because I also don't know what's the exact incantation of QuasiCores, and this documentation is really helpful. And in case you don't have IntelliJ or an editor which supports Scala Meta auto-completion, for the purpose of this talk, I honestly practiced this talk not in IntelliJ, but in a Vim, and just consulting this. This is the ADT of all the things that can happen. So for example, a type has a select, a project, a singleton, and this document is really useful if you don't have an IDE auto-completing for you. But for this live coding session, we'll use IntelliJ. Okay. So let's look at a problem that we'll solve during live coding. So imagine you are writing a web server, and you have a user model. It comes from the database, and you have a user class. It says an ID, a name, an email, and a registration time. And it's a REST API you're designing. So you're saying, OK, when I do a get on a user, I return the ID and the name and the email, but I don't want to return the registration time. To create a new user, you use the post route. Obviously, when I do the post route, I don't have an ID yet, because the ID would be generated by my database or the backend. And you just give a name and an email. And when you do a patches, as you can know, you can update any field in that model. And obviously, you can't update the ID of a user, but you can update the name. And if you notice, it's an option string here. So patches could be partial updates. So, and you defined your models like the user patch, user post, user get, these 3 objects to go along with your user object. And you see the problem here, which is, OK, this works, but next time I change name to be something else, or email, I want to change the class email from string to an email class, which is more strongly typed. Then obviously being in a statically typed language, you will get a bunch of compilation errors at the translation from the get to a business model, to the user class. But you have to go manually fix all of them. What if there's a way to automatically generate these REST models? So this is something that I would like to have, which is I want to just put an annotation called @resource on my case class, and I can say that ID, the ID field can only be propagated using the get model. The name can be get, it's required during the post, during the creation of the user, and it can be patched. The email, however, cannot be patched. Once you register, but it's needed during creation, and obviously when you want to fetch the object back, you want to get the email. And registration time is completely private. It's back into the server. The client does not need to know. So given these annotations, I want to generate these case classes and in a macro. So I don't have to so this is something that's generated. I don't want to write this myself. So this is the problem, and we're going to see if we can get this working. Okay. So as promised, can you guys see? Good, okay. So as promised, this is a new SBT project in IntelliJ. Nothing fancy is going on. I'm using Scala 2.12. I'm using Scala Meta 1.8 that Eugene released while he was on the plane. And that's just Scala test to write some tests. This is the Scala Meta Paradise 3.0 compiler plugin for getting the inline keyword, and this is it. This is my build.sbt. This is a test file that I wrote, and IntelliJ is complaining because it doesn't know all these resource get post patch. But this is literally copied from this slide, so I just didn't want to live code writing the tests. So, and I'm using SBT's should compile helper. So it's saying that after I have implemented these @resource, @get, @post, @patch annotations, this piece, user.get, should compile. And this should not compile. This post should compile. I'm patching the name with an option that should also compile. So these are my unit tests. So let's see. Can you guys see the terminal? Yeah? A little bit bigger? All right. How about now? Yeah? Back? Cool. So this is my SBT project. Startup SBT. And I want to do incremental compilation, but macros are in a separate compilation unit. So SBT doesn't know when you're changing the macros that you're actually changing parts of the code. So I'm doing watch, but clean and test for every time I save my file. So, okay. And yeah, I got all those errors saying it doesn't know all these annotations. So let's try to implement them. So let's create a new file. Resource. So let's create the annotations. So class get extends static annotation and post, put, and patch. And this also is an annotation, the resource. And now I'm going to use the inline def thing from Scala Meta. So I have to import scala.meta, everything inside it. So this definition is my abstract syntax tree of whatever I'm annotating using the resource annotation. So, but there is no data type like that, so they just use any. And I will come back to a second why every time you see any in a Scala code base, everyone's scared, but here it's okay. I'll tell you in a second. And okay, let's just return definition, and that works. That compiles at least. So, but you will still see. Okay, now at least it knows that these annotations exist, but it says that, hey, value get is not a member, so there's no user.get class because I actually did not generate it. Okay, let's try to do something. So we need to put the get, let's go back here. We need to put this materialize this get, post, and patch case classes inside the companion object of the class that I'm annotating. In this case, I'm annotating the user class. I need to put them inside the companion object. So the way to get the companion object, I don't know. How do I have a definition here. So as promised, I used one of these three resources. In this case, there was an example in the tutorial how to get the companion object. I'm not specifically how to get the companion object, but how to create an apply method in the companion object, and that's how I learned it. So I will not go through this, but it's pretty easy once you see. So there are two cases. So the simple case is when there is no companion object. So in that case, this is you pattern match saying, okay, the thing that I'm annotating is a class, and it has no companion object. So in that case, I want to return the class and create a new companion object. And then I use the QuasiCores, and I say object $class.name. And okay, that materializes the companion object. And the other case is where the companion object is already defined. And this, how do I know what QuasiCore to write? Again, it's in the cheat sheet right here. So this is the QuasiCore to pattern match or extract the case when a class and its companion object is defined. And mind you, all this, my IDE is auto-completing. So this is object and definition dot object. And for this to work, you need to be on the latest Scala IntelliJ IDE and Scala EAP plugin. So this is the case where the companion object is already defined. Okay. And what about if I put the resource annotation somewhere else? I put it on an object or I put it on a val. What should I do? That shouldn't happen. This particular annotation should only work for classes. It should not be anywhere else. So I can say abort the compilation with a message saying @resource must only annotate a class. Okay. All right, so there's some compilation error. Let's see what that is. So it's saying found type.name required term.name. Okay, that kind of makes sense because the name of a class is a type. So when you define a class, you define a type. But when you define an object, even if it's the companion object, it's not a type anymore. It's a term. It's a val. So okay, let's try to create a term.name. So I'm just following what my IDE is saying. And now it says, what's the error? So it says it needs a string parameter. So okay, fine. Okay, value. All right. So and let's get this is the class and the companion. Okay, and my favorite debugging tool while writing macros is println. You'll see why. So I'm printing out what I got. So let's see. Voila. So it printed that this is the case class. So this is the case class, and let's see if we can. And it created this companion object user. So I just did something. I created a companion object that did not exist before. So this is progress. Okay. Possibly. There we go. Yeah, that's a good catch. All right, so what do we need to do? Okay, we have the class and the companion object. We need to figure out all the constructor parameters to this class. So in this case, this is the user class, and I need ID, name, email, registration time. So, okay, how do I get the constructor parameters? All right, let's see what is available. Well, it just happens to be the first suggestion, the CTOR, the primary constructor. What does that have? It has sequence of terms, because in Scala, the constructor parameters can also be curried. So that's why you have a sequence of terms, but for my case, I don't care if they're curried, I just flatten them and just, so now I start my for comprehension. So these are the param, and I don't know, let's print line the param. Yep, so this is all the parameters, and you can see it comes with everything. It comes with the name, it comes with the type, it comes with all the annotations on it. Okay, so I again need to find the ones that have my specific annotations, these ones, get, post, patch, all my REST verbs annotation on it. So how do I do that? So again, tutorial or cheat sheet. So I'll Command F, look for annotation. Okay, that's how you do it. So you do this mod interpolator with at expression. Okay, that's apparently how you do it. Let's try that. Let's try if that works. So param, so this is the parameter. Let's look at its modifier. So a parameter could have multiple modifiers, obviously, like in this case. In this case, the name parameter has 3 modifiers, get, post, patch, but it could also have public, private, a lot of other things. So let's go through all the modifiers on it, and I'm only interested if it has one of my modifiers, that get, post, put, patch. And I looked at the cheat sheet. The way you do it is using pattern matching with, so using pattern matching using the mod interpolator. So if it's a get or a post or a put or a patch, then I don't know, then this is a parameter that I'm interested in, else I don't really care. I mean, this could be the example. This is the registration time where it just disappears. I don't really care about it because it's in the business model only, not in my HTTP REST models. So let's call this like new param, and print line the new param. So this should only, so earlier it was printing, if you see here, it was printing the registration time, and it shouldn't print that anymore. Okay, so we're getting somewhere. Okay, so one thing I notice is each time the parameters have the modifiers on them. Like I don't really, when I'm creating these new get, I don't want the @get annotation on the ID, or I don't want, when I'm creating the post model, I don't really want any annotation on the name parameter inside there. So, okay, let's blank that out for a change. So all these classes are case classes. You can copy them. And you can do stuff with it. So the copy, in this case, you can change its name, you can change its declaration type, you can change its default argument. In this case, I just want to remove all its modifiers. So, okay. And let's return with the modifier the new param I have. Okay. And let's call it, I don't know, params with annotations, or I just call it new params. So the type of new params is a sequence of the modifier and the parameter. So let's see what it looks like. Again, my favorite debugging tool, println. Okay, so I got a get is on an ID, a get is on a name, a post is on a name. This is perfect. This is exactly what I want. So I have this sequence of modifiers and parameters, sequence of modifier and parameters. I want to group by the modifier, the gets, like get all the gets together so I can create the get case class, get all the posts together so I could create the post case class. So basically what I want to do is I have a sequence of comma B, and I want to transform that into a map of A to sequence of B. So unfortunately, I mean, sequence do have a 2 map on them, but it just gives you a map from A to B. It doesn't give you a multi-map. So I'm sure many of you have gone through this problem yourself, and the way to do it is you group by the first parameter, in this case A, and from all the values, you take the second item. And I often add, this is such a useful thing to go from a sequence of pairs to a multi-map that I usually add it as a 2 multi-map on a sequence of pairs implicitly, but this is nothing to do with Scala Meta, Scala Macro. This is just plain old Scala. Let's see what my grouped looks like. Looks like it didn't work because this post should have more things in it, get should have more things in it, and this get has like just the list, and this it gets repeated. So how is that possible? If I'm grouping by it, it should be there should be just one key, but I'm getting multiple. The reason being the equality for any abstract syntax tree for the Scala Meta API is defined by reference equality. It says like, okay, if you use the same annotation, the get, so in this case, I use the same annotation, add get here and add get here, they're fundamentally different annotations because they just happen on different things. So you cannot do equality on them. The only equality is by reference equality. So in this case, so okay, I mean, I don't really care about that. I just want to group by, get my map A. So, well, I'm just going to group by the toString. Let's see if that solved my problem. Yep, this is exactly what I want. So I have the post on the name and email, patch on the name, and get on the ID, name, and email. This is exactly what I want. So I'm really close to my final goal where I want to, from this list of parameters, I want to create a case class. Okay, so all this line, all it does is just data structure manipulation in Scala. So now, so this grouped is a map of the string, the name, the verb, the get, to the sequence of terms. Okay, so grouped, and the ID tells me that. Or I could have just asked it here, and it would have told me that too. And, okay, so so let's map over it. So I know the first thing is an annotation. It's one of these annotations, and or the string representation of that annotation, and the params. So, and I want to create a case class out of this. So how do I create a case class? Again, cheat sheet. How do I create a case class? Well, that's how you create a class, apparently. So mods is public, private, case. This is the name of the case class. These are the type parameters. So these double colon means there's multiple of them. So if you're splatting a list, so obviously a class can have multiple type parameters. This is the constructor modifiers. If you have created a class, you can say the constructor is private, public, and all of these are optional. Obviously, like I may not have a class with a modifier. I may not have type parameters. And this is params SS because it's and it has 3 triple dots because again this block can be curried. So this is a sequence of parameters. So and extends whatever you can extend or something else. Okay, so I know how to create a case class. So case class $class name. I don't know what the class name is yet. And well, I can hopefully just use the parameters that I just got. And what's the class name? So the class name is basically so the class name is, I have up here the @post. I just have to remove the @ from the front and capitalize post because at the end of the day, I want this post. Okay, so well, class name equal to annotation dot strip prefix. I want to remove the @ from the front and capitalize it. So the Scala string library gives you nice methods like this. Okay. Let's see. well, new models. So these are my new REST API models, and it's failing to compile for some reason. Okay, so it says I have a string, but I need a type.name. So the Scala is, these AST data types are very strongly typed. So okay, fine. So type.name, and okay, so let's print that out. What are the new models I just created? Perfect. I just created the class that I wanted, the case class post, the case class patch, and the case class get. I just have to stick these new models into the companion object. How do I do that? I don't know. I actually looked it up in one of my favorite 3 cheat sheets, which was in this one. There was an example how to insert the apply method into the companion object. So the way you do it is a little bit arcane. It's not, if you think a little bit about it, it makes sense. So let's call it the new companion. So I want to I already have the old companion object, which I either created or grabbed the defined one. And again, these are case classes, so they all have copy. I want to take its body. The body for a object is actually in this thing called template. Eugene can answer that, why it's called template. But, well, I want to insert it into the template. So companion dot template and dot copy. I just want to insert it at the end. So again, this is like, if you know about, if you went to Martin's talk, like an object can have like early initialization, it can self-extend other things, it has parents, it has the self parameter and stats, that's like the body. So how do I know all this? Again, it's from this cheat sheet or examples. So, okay, let's get the companion.temple.stats, and all of this could be missing. So if I'm just going to do getter else nil, and append the new models to the end. Okay. All right. So this is an option. So good point. Hopefully that works. So and I just have to return the new companion, not the old companion. So again, I mean, this is the thing I used initially. So which is class, semicolon, object. This is the QuasiCore of a class with its companion object next to it. So I'm just going to do Q, return the original class. I didn't change the class at all, but return the new companion. Let's see if that works. So I can remove this print line now. So one caveat we missed was, let's see. So the patch is slightly different. The patch doesn't just blindly take this parameter name string. It puts an option around it because patches can be partial. You can only patch 5 fields out of 20 fields. So I didn't do that. I just pretended that patch is like the get or the post or the put models. So patch is special. So let's try to handle that. So let's create a new case statement for the patch case. I have to remove it from here. Okay, so at the end of the day, what do I want to do? Let's see, how do I create a new parameter? Like, I don't know how to do that. Okay, again, my cheat sheet of this. So how do I create a parameter? Command F, param. Okay. So there are two. This is the term parameter, and this is the type parameter. So I want to create a term parameter, not a type parameter. So you use the param interpolator, and these are the modifiers to the parameter, the name. This is the type, and the default argument, if any. Again, all of these are, the default argument is optional. So, okay, so I know I'm going to return something like this, where the name is the same as this parameter's name that I have, colon option some type equal to none. I don't know why. Okay, don't want to update. Okay, so the type, so basically what I'm doing is putting the type of the name, so the string inside an option and putting a default argument on it saying it's none. Because in patches, things you don't have to specify everything that you want to do. So okay, how do I get the type? Okay, so type is just param dot, there should be something called TP, okay, declared type. It's an option argument. Well, I know this is a case class. Why is it option? It should be a type argument, but these parameters are defined in a generic way. They are reused in other places in the AST that Scala Meta API exposes. So I'm going to do get. Okay. Before people scream at me for doing .get on an option, remember that why is .get bad? Because it can cause runtime exceptions when it's empty. But the runtime of a macro is the compile time. So if you do something bad, it's a compile error. So feel free to do these .gets and things in your macro expansion. Don't quote me on that, but yeah. Okay, this should be the param. Okay, so it says that it found type.arg and required type. It doesn't know that the type argument is a type. So I'm going to do something again, beautiful, and as instance of. Again, this is absolutely terrible. You should not do in real Scala code, but this is macro. It's going to run during your compilation, so it's okay. And the test pass. This is it. And yeah, and it turns green or yellow in IntelliJ, things pass, and I don't actually have to use the should compile. I can actually write user.get. I think IDE doesn't, IntelliJ doesn't autocomplete this case class because this user.get is actually being generated on the fly, but this should compile, and it still compiles. And you can see if I remove the email parameter, it should say that, it doesn't know unspecified value parameter email. So this is actual code that's compiling. It's just not fake tests. OK, cool. So that concludes the live coding portion of it. But to continue, like you can take this idea to insane depths, insane levels. Like, let's say you have a data access layer. You can generate this whole data access layer during macros expansion. So if you have something, a very simple facade over your database, which just does a REST API, and all it does is just updates. It's a CRUD app. You can generate the whole everything, the whole shebang. You can even go generate the SQL if you want, and just annotate as resource and go to and just define your case classes. You can even generate the models, the database, the table, the SQL. You can even generate the routes if you have like a Play app or a Finagle app. Fortunately, we won't have time for the problem 2, but I'll give an update. So if you see here, I had a problem here. Like I did this. I wanted to update a very deep thing in my case class, which was companion.template.stats, and I had to do this .copy. But there are some nice paradigms. They are called lenses where you can update. Like in this case, you have an engine. You have a garage which has a car. The car has an engine. The engine has a version, and all you want to do is upgrade the engine in your car, and you have to do this copy. And again, this is possible using some nice macros. And this was supposed to be my talk on def macros, but it got released a few days ago. So this is next talk. This is pretty much it. The code is live. You can check out these 2 repos. The slides would be online. The problem 1, the first one that I did live coding is over there. The second problem using for lenses is the second one. Little plug, I work in a hedge fund in New York. We have offices everywhere in San Francisco, New York, remote. If you love Scala, Spark, algorithms, trading, come talk to me. And yeah, that's it. Please vote. And any questions?
So in a couple of slides before, you were saying how, and I agree, obviously. Yeah, no. Right here, yeah. You were going over how you could use macros to generate pretty much everything.
Yeah.
The question is, would you, in your experience, say that that is an advisable thing to do, just because you can do something?
No, I would say don't go so crazy, but I was just saying what's possible. But probably not, because if you're just developing a CRUD app in the first place, it's kind of boring work. But
Sorry, what did you say?
if you're just if all you're developing is a web app who just has like REST APIs that writes to database and crap things out, like I don't need Scala or anything for that. But this is a very common case that I actually use in production, where I do have models and they do have well-defined REST versions of it for the get, post, patch. And I do use this in production, but I don't actually do this in production because I do more things in it, like I do some sanity checks, I do things. So in my case, I don't do it. And you wouldn't in real life, because your app is probably more complex than just a writing and reading to database. So yeah, hopefully that answers your question. Yeah.
User.get, that IntelliJ didn't get
Yeah.
it.
So
isn't that annoying
so
in the day-to-day thingy?
Yeah, so the JetBrains guys who were outside, they told me that I should update my IDE and this should work. And I didn't want to do that before this talk, so.
Makes sense.
But this works, like you can actually, this resource annotation, it was read before, but once I did it, and you can think there's a way, you can click on this thing which says what it expanded into. And it doesn't show it that, it does know that I created an object user, but it doesn't put the classes inside it. So they have this little squiggle thing which says expand scala.meta macro, and the support they're working on right now, and it's going to be better.
I would like to ask, does it influence somehow on the compilation time?
So usually I put all the macros as a separate, so I have a multi-module build. I put all my macros in a separate module, and I have everything that depends on macros depend on that separate module. So as long as I'm not changing that module, which is the macro code, the compilation is fine. Yeah, if I change the module, not only SBT test or SBT compile wouldn't detect it, I have to clean it manually. It doesn't detect. And that's the problem, I think, that was mentioned in this conference 3 or 4 times. And hopefully they'll have a fix for that. But usually you try to put all your macros in a separate module from your actual code.
Hey, thanks. I have a question about what if you have for your, like, what if you already have this object user and you just, like, there is some code already and you, with your macro, you add these like helper classes. So we have kind of similar annotation, and there is a problem that if you have a compiler in your like manually written code, so the macro will rewrite your companion and you won't see the exact like line number in the error message. So the compiler is going to fail on your manual code, but the error message would be not so like helping.
Right. I believe in the new Scala Meta, there are ways if you want to write really, really hygienic macros. Like if I want to make sure that no one actually else declared the get class before, like by hand. I can do that. I can do a check right before I manifest those that these objects don't exist and give a better error message. And I think this project is so new that those patterns haven't been established yet. And I believe we would discover as a community those patterns as we go.
So you mentioned, is it working? Oh, yeah. You mentioned when you defined the resource annotation, you had to use the type any. Why was that?
Right, because this type would be, if I were you, it would be an AST, and it's just Scala Meta doesn't have such a type that's exposed to us. And honestly, you could do anything with it. You could remove it. You could remove something, or you could, you have a class and I can return an object. And so you can't really type this well. And back to my previous point, if I do screw ups during the runtime is the compilation. So, okay, not a big deal.
Hi. There is a case when you when the class defined and companion object already defined. Yeah.
Yeah, that's
it. Is it depend? Is it strictly the case when companion object defines right after the class?
No, that's not. Let's try it. Object. That's just the QuasiCores extraction pattern. So. So it doesn't really matter. So hopefully, I might be wrong. No, that works.
Oh, okay, thanks.
Yeah.
So just for fun, say like, can you just
I like fun.
Add well, why put it a type like string and leave the right hand side and see what's going on?
Like this.
Like this.
Yeah.
Yeah. So you see the line. This is what I was talking about. Yeah. So is there any like help here?
Yeah, not that I know of. Yeah.
Okay, thanks.
Yeah, that's a great point. So the point is, I made a compilation error, and it says line 4 of macro. It doesn't really tell me that this object was created on the fly by me. But yeah, that's a good point.
Do you think it's possible to make this work with for example, play JSON macro?
Yeah, of course. Yeah. So if you're familiar with the play JSON macro, you have to put that implicit val format inside the companion object. I actually don't do that. I generated on the fly using a macro. There's actually an open source project. It's called Kiffy JSON, which also does that. So. But they don't use Scala Meta, they use Scala Macros. But yeah, totally. All right, so that was it. Catch me after the talk if you have more questions.